In this video, we're going to talk about some of the mental models that I've developed that have helped me figure out, navigate, and ultimately use Git effectively, pain-free, headache-free, right? I can just understand what's going to go on. And I've been able to flip what is turned, what a lot of people feel like are cryptic commands into actual actions that support me as a software engineer and help support the teams and people that I work with. So let's just jump right into it. The first thing I want to talk about is what is a commit, or the anatomy of a commit in Git. So let's just say up here on the board, we have a commit, and there's several bits of information that make up a commit. So we have the author information. We have the actual contents of our change. We have time. And then this is the real important one. This is the note I want you to take. The previous commit. The previous commit, a reference to the previous commit, is embedded in the current commit that we're about to create. And that's really important information because it's one of the root cause for some of the other issues that people have later on when they try to do things like rewriting history, which I'm sure maybe you've read online, or when people try to do rebases. It's this element of a previous commit that is fine. It works just fine, but it's something that really throws people off and causes some hiccups that people aren't quite aware of, which is like, why did my commit hashes change when all I did was rebase, or all I did was change the message, or all I did was amend my commit? So in the commit, when we get a commit, we get on the other side of this. So these are our inputs. And then we'll just summarize and say on the other side of this, the output is the SHA-256 hash. I'm going to summarize it like 3B4. We get something like that, 3B4. And so whenever we have our commit, if we ever change any element, any of these inputs of our commit, we will get a new hash every single time. So if you've ever done an amend, or you've ever done a rebase, or you've ever squashed commits, you don't ever get the same hash again. They're approximately, unique for every commit, for everyone, for every person in the world. So just keep that in mind. This element of commits, we cannot actually change a commit. Commits are immutable. If we make any change to it, we get a new commit instead. So keep that in mind. So that's what I want you to hear about first. So first with the commit. So let me erase this then. Let's clear the board. And then let's talk about the anatomy of a branch. Well, a branch is one or more commits. So if we're just for this example, I'm just going to use letters here. So in our example here, we're going to have time. So time flows left to right. So anything that happens here is earlier. So we have A, and then at some point, we're going to have a commit here, B. And I want to make sure that we call out that even though time is flowing this way, just remember that reference here. B is pointing to A. This is not bidirectional. This does not go both ways. This is B has a reference to A. So when we add commit C here at some point, it looks like this. I'm going to use some jargon here when we talk about a branch. A branch is a mutable set of immutable commits. We talked a moment ago about how commits are immutable. You cannot change them. You can only create new ones. A branch, on the other hand, is completely mutable. We can, even though we're only ever appending commits to the end of it, we can change this at any point. So let me just call this out. Let's say that this is the main branch here in our repository. We can change this at any point. The branch is flexible through things like rebases, through resets, through checkout, branching with checkout. We can make main B, at any point we can make main B anything. This is completely flexible. The commits themselves are not. So that feeds into our next, the thing here we need to make sure we know of, which is, rewriting history. I'm sure it's something you've read online or heard online at some point. So, and a branch, it's append only. So we can only ever add things to the end of a branch. But let's say we need to go back here and we can actually make a change to the contents of this commit, or what this commit is. And So I'm going to use the mathematical. There's we use like a tick in math, and they call it prime. So I'm going to use this prime symbol here to denote that we actually have a change. This is not A, this is A prime. We had to make a change here. Let's say we found a typo in this message and we needed to go back. We used some sort of action to make a change to that. Well, because of this relationship here that everything depends on something before it, now that we've changed A, that means we're also going to get a new commit hash for B, and we're also going to get a new commit hash for C. So this is a really important element of Git, and what is going to lead to a lot of your friction here is that when we change anything in the past, it is going to have ramifications for everything else that came after it. So I hope you can see that by having this impact of if we ever change anything in the past, it has implications for what it's going to, how the commits look like in the future. I think we're going to be good there. So then let's talk about another area that people generally are unaware of. So if we have an example where in this situation, let's talk about we have a server, something like GitHub, something like Azure DevOps. We have our repo on the server, and then we have our local repository. So let's just say we have GitHub out here, and then we have our local repo here. Normally, if we think about the main branch, we think, oh, we just have the main branch. It's the only branch we have. There's a line of thinking where there's only one branch. But in this server local repo model here, there are actually going to be 3 copies of that main branch. So in our local repository, I'm going to draw these lines here. We have, on one side, we can say we have our workspace. And on the other side, we can say we have remote tracking branches. So whenever we do a fetch, or whenever we do a fetch, or whenever we want to pull something from the server, there's a copy of the main branch here that is tracking from the server. And then we have a copy of the main branch over here on our called the workspace side. Whenever we want to see the files on our system, whenever we want to see the pending changes, we want to make changes. This is what we're doing. We're working and we're making edits and modifications to the workspace copy of the main branch. When we want to send the workspace to the server, it's done with a push. So push is what happens when we send main from our workspace to the server. Now, a lot of people have heard pull. I think everyone knows pull. A lot of people have probably heard that pull is not a real command. It's actually an alias for fetch, and then either merge or rebase. So whenever we do a pull, it's actually doing a fetch. And it's downloading the main branch from the server to this remote tracking branch copy of main. And you can actually see this in your repository. These are the branches that are prefixed with the name of the remote. So in your repository, you'll see a branch named origin main. And then when we go to actually bring the changes from here to main, well, that's either done with rebase, merge, or another option is some sort of reset. This is how changes flow from the server down to the remote tracking branch, and then they get modified into our workspace branch. So having the ability to, we have this middleman here for the most part, this copy of what's on the server, that's really important. And then just be aware that these branches can exist in different states. This remote tracking branch is not updated in real time. It's only updated whenever you do a fetch. So there's activity going on out here in GitHub. Coworkers are sending things out here. And then at some point you download, maybe in the morning, on Monday morning, you're going to do a fetch and you grab the latest from main. Activity is going on out here. And then at some point you update here your workspace version of it. These things don't stay in sync automatically. It's up to the commands through push, through fetch, through some sort of rebase that this is going on. Right? So this is really important to know that we end up getting a specific branch to track what's going on in the server. So, all right, we got this here. So let's take a look at some examples of what causes problems for people. So in a push, when we want to do a push, the server has 2 options. It can accept your push or it can reject your push. So let's say out here in our local, we have commits A, B, and C. And remember, this is time. Time's going left to right. These arrows are pointing back to kind of remember in your mind that these things depend on each other, that C depends on B, when B depends on A. Now, the GitHub has the same thing. It has A, B, and C. But the difference is that since we last got the main branch, someone has added commit D. Right? A coworker pushed their change out there. Now there's commit D. And while we were working on our change, we added commit E to our local repository. So in the case of a push, when we want to do a push, what's going to be the result of that push? And it's actually going to be, it's going to get rejected or denied. And that's because, going back to the anatomy of a branch is append only. On the server, it is not trying to reconcile or rebase or merge or integrate your changes in any way. The server is evaluating, did your copy of the branch, what you're sending me, is it additive only? And if it's additive only, then it will accept your push. That's how the server is operating. So in this case here, I hope you can see that this is not additive only. We're missing something. So this is where we now need to do some sort of fetch, because we need to bring down the latest from the server. And now we need to, I'm going to recommend fetch and rebase, or you can run it like git pull -r. You can make that your default if you'd like. So we're going to do, we want to do the pull and rebase. So now we get D, and then Git also figures out that, okay, we need to reapply E, but now we have, going back to this E prime, we have something that looks like E, but is not. It is a different hash because Git had to regenerate this commit because what it depends on is now different. Now, when we go to push this again, it's going to work. We're going to get the green check. The server's going to accept that. Now it's going to have on the server, it's going to have E prime up there as well. And everyone's going to be happy because our changes went up to the server. The last thing we're going to transition into are the git reset. And then there's not actually, you have to use, there's soft resets and there's hard resets. So let's talk about the hard reset first. Remember we said a branch. A branch is a mutable set of commits. We can change with the branches. So if we have, going back to, A, B, and C, and let's say we've added D and E, but then the server has A, B, C, and now they have G. All right, so this is the server. And this is my local repo. There's another way to bring down the latest. Let's say in our example here, we have some extra commits here, and we want to bring down what the server has. We actually don't care what about D and E anymore in our example here. D and E are irrelevant. We're just saying like, hey, I actually need to discard some of my work and accept what the server has. So a rebase here wouldn't be super helpful because a rebase is going to preserve what we have. It's going to bring the latest in and then reapply what we have. So in this case, a hard reset would be really effective. So what we can do is we can do a fetch into our origin main branch. And then through a hard reset, we can tell Git to a hard reset means discard everything that I have and make my current branch look like what I tell you to make it look like. In this case here, the remote tracking branch origin main. So now Git is going to just completely wipe out what we had in our branch, and it's going to make it look like G. So in times where you have completely goofed your local repository, but the server has what you want, a hard reset is your shortest path to get your changes from the server back into your local repository, back in business. So whether you have rebased the wrong branch, whether you have merged the wrong branch, we don't have to think about undoing those operations because a hard reset allows us to completely just wipe the slate clean and make our current branch look exactly like whatever we tell it to look like. So even though we're on the main branch, let's say we have another branch out there called develop, and we actually want the main branch, let's just say my example, we want the main branch to look like develop. We can say a hard reset on the develop, and that will completely erase everything that main has and make it look like develop. And then we're like, oh, dang, that was also the wrong thing. So now we can say, hey, hard reset back to main, and the main branch will look like the main branch again. So this is a really powerful way to get your repo back in order when you're like, oh, I created off the wrong branch. I've done a bad rebase. I've screwed up something. Hard reset is what you want. Very important. So let's go back. So in the hard resets, there's one more where we can go. It is now the soft reset. The soft reset. A lot of people have heard of squashing commits. Really helpful, very useful, lots of utility there. But squashing commits is kind of like, oh, okay, there's no squash command. How do I do that? Well, Git gives us the soft reset. We can tell it to discard some number of commits, but preserve those changes. So let's say we're back to A, B, and C. I'm actually going to add D in here. So we have A, B, C, and D. Now, let's say that in our branch, we want to identify that C and D are, I just want to commit, I want to bring these together. I don't want to have C and D. This change had a typo in the message, but I just want to get rid of these two commits, but I want to hang on to the changes. So Git will aggregate what is the changes of these two commits, and it'll move the files back to the index/staging. Staging is not really a Git term, but a lot of people know it, so I'll call it the staging area. Now, Git has got rid of these, and just say C and D are down here. So now we just have a bunch of changes in our repository. Now we can make 5 commits out of this if we want, or we can recommit them all together. Now, whenever we want to commit, now we end up with a brand new commit. I'm just going to call it F. So now when we recommit, we get something brand new. So if you ever need to undo some number of commits, or you want to, bring things together, squash things, the soft reset is going to be your best friend. So I hope this was helpful. These were the mental models that I rely on. These are these things that we talked about here, understanding how the commit is structured, understanding that a branch is flexible, knowing that we can do hard resets and rebases, and how a rebase is going to, if we rebase something, it's going to change the, it's going to rewrite history. It's going to change whatever came after it. These are all the things to make sure that you know, so that the next time you go to think about, how do I need to do something in my day-to-day? How do I squash my commits? How do I fix the branch that I'm on, etc.? These are the new tools in your toolbox to help you get by. Thanks and good luck.